We have two speakers for you today, Tom DiPalantonio, AFL's Global Account Manager for Verizon, and his special guest, Dustin Munchell, who is a Principal Engineer in the operations area of a Tier 1 ISP. For some background, AFL stands for America Fujikura Limited, and we are part of Fujikura, a $7 billion global manufacturing and technology leader in the telecom, energy, automotive, and electronics industries. AFL is over a $1 billion company that focuses on fiber optic products and services. AFL's product line offers its customers a comprehensive end-to-end solution that starts with fiber optic cable and spans connectivity and equipment to test, install, and maintain the network, conductor accessories, all the way through services and training. And now I will pass it over to Tom DiPalantonio. Tom?
So thank you, Barbara. Appreciate it very much. And as we go forward, I want to thank our audience. I want to thank also Dustin for taking part of this. We did a cleaning and inspection webinar not too long ago, and then this. Hopefully this will be just as effective. So thanks again, Dustin. And as we move forward, any questions y'all might have, please send them into the chat, and we'll address those at the end. Going forward, what we wanted to do is capture on why fiber management, and really these are going to be the key topics that we talk about. One is being able to maximize the available space that you have. As the bricks and mortar starts to shrink down, so does the opportunity to reach out and go deeper into the network. So you have to be more efficient in doing that. How do you future-proof your network? We're going to talk about that as it moved from 10 gig to 40 gig to 100 gig to 200, 400, and even beyond. We're also going to talk about how do you generate revenue faster? What are some of the tips and tricks in doing that? That also by generating revenue faster, you do that also through reducing your cost. What's the cost factor, or let's say the value proposition? And then how do you improve your network performance? Very, very important to understand that. Dustin's going to talk a lot about that because through the eyes in which he has seen a lot of networks and their performance. And then you want to be able to grow at your desired rate. So the purpose of this too is to help the audience understand is that you want to buy what you need for that given time, but also that you have good expansion. So with that, Dustin, did you want to chat on this just a few minutes?
Yes, Tom. Well, thank you for having me join you all again. So a lot of this, so why do we deal with fiber management? And I always use it from the perspective of the technicians. So, you know, from a technician's perspective, they don't want to be walking into a space and find that they need to deal with a mess on their hands. So, but yes, it also ties into network growth, you know, generate revenue faster by being able to put in orders quicker and having to deal with reduced costs with as far as installation time, as well as further maintenance with regarding to improving your network performance and future-proofing your network. You know, we'll see later on where we have a couple scenarios that, you know, people didn't necessarily plan for the future and they have a mess on their hands that they have to deal with. So yeah, you gotta be able to deal with your fiber management with inside your networks to be able to grow your network.
No, that's a great point and a leading segue into our next slide, which, hey, if I'm going to give you a work order to go run this order, here's a perfect example of how would you deal with this nightmare?
Yes, certainly. So when you walk into a space, especially like you see there on the left, you have a lot of cables, jumpers, et cetera. So if you're walking into a space like that, you have the potential of causing additional network outages. Simply because if you're wearing a tool belt, maybe your tool belt gets caught on one of those cables that are strung within your work area. Also, too, you run into these spaces sometimes where the lighting isn't always the best, so you can't necessarily see everything. You have all these additional cables that are in your way, and also, too, it's a safety concern. You know, if you're walking into this space and you do have the poor lighting situation, the cables aren't managed properly, and you happen to trip and fall over one of them, It could end up being a triple whammy where you've caused not only a network outage, you've also hurt yourself in the process. So proper fiber management and cable management in general is very important from the technician's perspective that's there on site, especially, as well as all the other items that we touched on previously. But from the technician's perspective, especially because, again, as I mentioned a minute ago, they're the ones who are working in this space and dealing with, as you see here, the spaghetti junction.
Yeah, this is really a poorly built system over time, you can tell. Hey, as we advance forward here, we wanted to capture the slide. You and I talked about this. Success and failure. We've talked about, there's detailed Telecordia documents for how you do what you do, as well as access front and back. And why don't you tell the audience a little bit about, multiple touch points, as you can see, and how the one on the right is well dressed as opposed to the one on the left.
Correct. So when you're looking at a panel such as the two here in the examples, when you have fibers that are not managed very well, you deal with things like bend radius potential issues, and that's where you have the fiber that's bent beyond the radius that's intended for the jumper itself. And what that means is that the light will then bounce outside of the, you'll have a light loss issue. Okay. Not to get too in depth in that, but also too, the way the fibers are dressed, you see the one on the right has a lot of nice sweeping curves. There's none of the fibers are really bent beyond the bend radius capacity. And when I mentioned bend radius, think of it like a hose. Okay, so if you take a hose, if you go outside in the backyard and you have your hose turned on and you bend your hose, right, you're going to have lower water volume coming out of the end of the hose. Light can kind of act the same way. So when you bend your fiber beyond a certain capacity, less light will come out of the end of it. And there's a few other things we'll touch on later that can potentially happen. But, having those nice sweeping bends within the back of the panel, that certainly assists with a lot of your potential bend radius issues. Also, too, if you're trying to do any sort of management with inside the panel on the left, it's going to be very difficult when you're dealing with a 144 panel or whatever the volumes are, and you're trying to get your fingers inside those panels to go ahead and extract connectors and do your inspect and cleaning and your troubleshooting and hooking it up to assess it.
That's a great point. So Dustin, when we put this slide together on the good, bad, and the ugly, we wanted to show the audience of where a good fiber panel, if it's not maintained well, or even if it's established well, where it could be or where it could go to. And I wanted you to talk more about that.
Yeah, certainly. So let me just kind of start with the ugly and we'll finish with the good. I always like to end on a good note. So looking at the ugly, as you can see here, when I'm a technician and I approach that particular nest of yellow jumpers, that really just doesn't make my day. I look at that and say, oh gosh, I got to go ahead and work inside that particular environment. So there's a lot of issues there. Obviously, it doesn't present a very good image as to how how your company and or your team takes care of the network. So it does have sort of a poor image, if you will, of the way the network maybe be taken care of. But also, too, there's a lot of potential there for outages for other services if you're trying to work and do maintenance or installation or disconnects on that particular ugly route. And we don't want to see that, obviously. That's not something that you want to see on a regular basis. It just doesn't make your day. It makes things frustrating when you got to work inside that type of environment. Moving on to the bad. So what you have here is a lot of cases where jumpers may have a bend radius problem. Okay, and as I mentioned with bend radius, so I kind of use the analogy with bend radius like a hose. If you go in the backyard to your hose and you turn your spigot on, you take your hose and you bend it in half. Well, the volume of water that's going to come out of that hose is going to be less. Light is the same way. So if you take a fiber jumper and bend it beyond a bend radius capacity, by the way, excluding BIF fibers, okay, we'll talk about that later, bend insensitive fibers. Standard legacy jumpers, if you bend them beyond a certain bend radius capacity, it will lessen the volume of light that's coming through it. So you could have potential issues there. But also, too, the way the jumpers are kind of crisscrossed from one another, if I'm trying to do maintenance work on the car that's in slot number 2 from the left, and I have a jumper that's plugged into slot number 3 from the left that's right in front of it, and I can't do any sort of maintenance or do a card swap of card number 2 because that jumper that's plugged into card number 3 is in my way, well, guess what? Now I'm potentially taking 2 customers out of service. So we have bend radius issues there, jumpers that are kind of crisscrossed in front of one another. It's obviously not a good scenario. Then ending on the good, so there you see a very well-managed fiber routed piece of equipment. Jumpers have nice clean sweeps. They're managed properly. They're utilizing all the paths that are there in a correct form, and it just looks nice, and it presents a well-managed network.
Yeah, and I wanted to take that good slide and really expand on it, the best practice. So, you and I have talked about this, and I know you're going to go more into details, specifically on the one on the left, but, what through scalability and flexibility that we talked about from the beginning, some of the things that, I'd like you to hit on, Dustin, is, like the small form factor, right? As the platform starts to shrink and the connectors start to get smaller, there's different scalability but flexibility of these platforms by having different trays, having different cassettes it can plug in. As you can see, the one on the right has latching mechanisms because the connectors are becoming very, very small. So they, so it's built that way. What's your thought on best practice, especially starting with the slide on the left?
So yeah, the what you see here is you'll have different panels and different flavors from varying manufacturers as far as the different ways fibers can be routed. And as we grow or as we transition our networks into higher volumes and smaller spaces, that's becoming more and more of fiber routing is becoming more and more of a necessity. So, you've had in some cases where you had a panel that supported 144 fibers in a maybe thinking it might be an 8 or 10 RU space in a rack, and now you have them where they can be double, triple, quadruple that in a much smaller RU space, in a rack unit space. So the size of the jumpers becomes smaller. The connector sizes become smaller because they can be, you can get higher volumes within a particular panel. And that means, too, that a lot of cases there may be requirements that you might need smaller diameter jumpers. Our legacy jumpers may be 2.0 millimeter, and some of the newer panels may require that you use 1.6 or 1.2 millimeter jacketed jumpers, and that just means the outer diameter is a bit smaller, and it's going to be a bit supportive of the higher volumes inside those tray clips. The other thing that I tend to do, and I tell this to everybody, whether it's fiber or whether it's copper, whether you're dealing with an old school DSX or POTS or what have you, I kind of take a piece of equipment and or a panel and I split it in half, right? So, I kind of consider that middle segment the DMZ, or the demilitarized zone. And I do not cross that segment or that section, right? That invisible line, that invisible border. So any connectors that on a piece of equipment or on a fiber panel, whether it's a MUX or a fiber panel or a piece of network equipment, I kind of split it in half, and I take all my jumpers and I route those that are on the left-hand side, they go out of the left-hand side, and those that are going into the right-hand side go out of the right-hand side. So I continue that sort of rule to ensure that I don't have an overabundance of connectors going out on one side, because as you can see, those clips are not necessarily designed to manage all of the jumpers that are inside that panel. So And again, that rule is not a new rule. It's something that, we've held true for a long time within the copper network, or we should hold true in a copper network. But I've seen evidence where it doesn't always hold true. So yeah, the fiber management clips are there to prevent, number one, bend radius issues. Number two, they kind of, as you manage those trays and slide them in and out in those cassettes, and you move them in and out to add orders or disconnect orders, they kind of keep your jumpers also out of the way to prevent them from getting pinched inside the panels as you close the doors and slide the trays in and out. So there's, and they also to keep the bend radius rules adhered to.
That's a great point. And that really sets us up for the next part, which is fiber slack, right? Spooling, and how do you do it, and how you should really spool the fiber if it's you have too much slack, or sometimes when it's if the jumpers are too short. So I'm going to throw this over to you. What's your thought on this?
Sure. So when it comes to fiber slack, it usually begins either at, I always kind of say that fiber slack begins with either one, the decision of the technician to grab the right length jumper, or two, the network planners and the engineers who designed the installation and ordered the length of cable that was necessary to connect the piece of equipment. So you kind of have two areas there that you have to be mindful, and it all has to come down to what is the proper length. So the spooling mechanisms that you see on a lot of newer equipment, and actually they've been around for a little while, these spooling mechanisms are there and designed to support any additional slack. They have obviously the sweeping bends to support the bend radius requirements necessary to route fiber, but there are some rules that are involved with these spools. Things like don't zigzag jumpers, don't double wrap around the same spool. And most of the manufacturers who have these designed within their network, they have, some of them even come with little booklets and little, images to say what to do and what not to do. So, if you adhere to those rules, you'll usually be in pretty good shape. But when you zigzag and double wrap around spools, you're going to create yourself a problem over time when it comes to managing adding additional circuits or disconnecting. If you're trying to disconnect a circuit when it's double wrapped around a spool, that's going to cause some problems. You're not going to be able to get that out of there. And especially as the network grows, you see the image on the left, that's just two circuits. So we're at the very beginning, the infancy stage of that piece of equipment as it's being installed and grown. So as equipment and as circuits are added to that and you add additional fibers, obviously those spools are going to get very utilized and congested. So over time, if you don't begin the management properly, you're going to create yourself more problems as you grow the network.
Now, when you look at the best practice comparison, and this kind of, the last slide that leads into the one on the left here of proper management, we're talking about the drip loop and it's, adequately to be able to manage the breakout, as opposed to that on the right. I know you've seen this before. You and I both have seen a lot of this, especially, the fiber slack and just allowing that spaghetti junction to the right. What's your thought of why this happens?
Certainly. So what it's a number of things, right? So what you typically have is on the right during an installation of a piece of equipment, it begins obviously with good engineering, right? Good engineering, proper engineering, ensuring that your lengths are documented and all the supplies that are ordered for, whether it's the jumpers or the cables, are engineered and ordered correctly as far as the lengths are concerned. That way you don't have to manage a whole lot of excessive slack, and you can have a nice drip loop and bend radius that's going into your equipment. Secondly, it has to do with proper training. And, I always say that, good fiber management and good equipment installation begins from the very beginning. So if you have a good, well and neatly installed piece of equipment, and the fiber management is done very cleanly, very neatly, usually that's going to initiate additional well-managed, proper managed fibers after that. Meaning, if you start out with a very good job, usually the people that are going to follow you are going to continue that work. If you start out with a very poorly managed fiber network or piece of equipment installation, usually the folks that are going to follow that are going to use that as a reason to not clean it up or not do it properly. They'll use that as their reason to continue the poor practices. So, once you start with a good, clean installation, usually you see good, clean installations thereafter in and around that particular piece of equipment, because you don't want to be the guy that kind of had a, ugly sore thumb sticking out when somebody did a really, really neat and proper and clean installation. So also, too, you'll have scenarios where in the image on the right, the jumpers are all, obviously we mentioned this prior, the jumpers are all zigzag, they're knotted together, and trying to do a disconnect, for example, out of something like that, or trying to trace out a jumper to try to figure out which one is yours is going to be a real problem within the rat's nest that you have there on the right.
Yeah, that's it. And we're going to talk about that in just a couple more slides. As we go forward, I think this is another image of what you were just talking about, especially the one on the right with incorrect running of jumpers that are not managed properly from, perhaps design or just what they had, for use at the time, right? As you can see them hanging down. This is another great image of what you don't want to do on the right, and obviously a great image of what you do want to do on the left. Don't you agree?
Absolutely. So yeah, with especially the image on the top, a lot of that on the right top image, a lot of it has to do with proper training, making sure that the technicians that are doing the installations understand the rules that are in place or what you expect of them for the installation, things that you don't want them to do, and then also too having a good, adequate auditing that's going to occur after the fact, so that way you can go back and reinforce those rules, because not doing it correctly, it's just going to expand over time, and you're going to have further mess on your hands. But the image on the bottom, a lot of times when you see something like that, where you see jumpers that are just strung across relay racks in a network center environment, or in a central office, or at a customer prem, or CEV, whatever it might be, when you see jumpers that are ran across that, there's a couple things that are happening there. Number one, it's we got to get the order in right now, and we can't wait on something to be re-engineered if we don't have a path between lineup A and lineup B. So the final last words is always, we'll go back and fix it. Well, then 2 years, 3 years later, it's always, yeah, we'll go back and fix it. And it's never going back and fixed. But having that, open line of communications between the field and the engineers to say, hey, we need to have an additional path between two lineups to, correct this particular type of fiber run here that you see in the bottom image. That obviously there's a lot of bad things that are happening there. You have the jumpers that are kind of crossed over AC lighting, and they may exceed some sort of drip loop, or they could cause a bend radius problem, or for that matter, they are a safety concern. If the lighting isn't adequate in that particular space, a technician could walk right by and, get hung up right in their head by the fiber jumpers that are strung right across the relay rack. So, yeah, but usually when I see this in the field, it's the famous last words are, we'll go back and fix it.
Yeah, we've heard that quite a number of times, haven't we? as we move forward into fiber routing, with the amount of fibers that are being deployed, and we're going to talk a little bit more about connectorization and how that is reduced. But before we get there, here's a good example with some of the trays and what can happen when you start putting more and more jumpers on top of one another. One is that you can have some type of macro bend, and we know what the macro bend. I'm going to let you, Dustin, talk about what a macro bend turns into, as well as crushed fibers that we see to the right. So, what's your thought on this?
So yeah, and again, this kind of goes back to that open communication between your operations teams and your planners and your network engineers, and or maybe if you're in an environment where you do your own network planning and engineering, just kind of planning for growth. So here you see with the images on the right, the plan for growth is obviously exceeded the capacity of the pan duct that was ran there, the duct work there, the kind of orangish duct work that you see. So the technicians in the field, the covers that are supposed to go over top of it have busted at the seams and kind of looks like your waistline at Thanksgiving. So, using Velcro to kind of keep everything tied in correctly. But again, that goes back to that open communication between your operations teams and your field engineers and your network planners, so they can go ahead and then plan for transitioning that fiber work maybe into a newer piece of duct work to accommodate all those volumes, that large volume of fiber jumpers. But as those jumpers lay in there, if I'm trying to do a disconnect on a jumper that's in the bottom of that pile, it's going to be difficult for me to pull that jumper out to perform that disconnect. So I can, have that space freed up for newer services if I need to go ahead and add additional. So, it goes back to network planning and ensuring that you're going to be able to accommodate the volumes that your network is planning for and future-proofing the installations.
Yeah, that is a nightmare when you don't future-proof, and I think that's when we spoke about it on the first slide of what this webinar series was going to be about. One is obviously future-proofing. How do you do it? And this is a perfect slide of that. Another is scalability, right? If you're going to scale it, or let's say the design is for growth, which it should be over time, is how are you going to handle that? And the slide, or I should say the pictures to the right, shows that wasn't handled properly over the time, whatever that course of time has been. Going forward, we're getting close to the end of this webinar and wanted to bring in some of the best practices. So what should it look like? And what we wanted to do is capture various, whether it be vertical or horizontal, of the different bend radiuses, as well as attachments, whether it be like the extended latch tabs as you see to the right, and the trays of the cards. And this is the way it should be. Don't you agree, Dustin?
Yes, absolutely. And and here's one other thing that I do want to kind of touch on, and varying corporations and manufacturers have their own installation standards that they have spent a lot of time designing, writing up, and implementing within their company or their instruction manuals. So you'll have things like, there's Telcordia guides, there's sometimes internal practices that various corporations may follow for installation standards. But also, too, don't forget that the manufacturer of that piece of equipment has a lot of times instructions in there on how to properly run your connectors and what to do and what not to do. They've taken some time and also incorporated that. So don't forget that, and don't forget when you're in the field, you may need to pull out the manual and see during an installation, what should the proper routing be. A lot of these pieces of equipment especially network gear, has fiber routing management built into the bottom trays or the top trays, depending upon how the fibers are routed inside that piece of equipment. And they have rules that are already dictated and put in place inside their documentation. So don't forget about that, and you know, read up on your information and properly educate your field to understand how the fiber routing should be on a particular piece of equipment, because it's not always the same. Different manufacturers have different methods on how they've done it. So take some time and read up on that and educate your field and educate your team and educate yourselves on how the fiber management should be with that particular piece of equipment.
So Dustin, we're almost at the back end of the webinar right now. We're going to talk about some best practices, a couple slides of best practices for the fiber routing. Now, part of that, though, of making sure that it's routed properly is that the beginning part, which is even prior to making sure that it's managed properly, and that is you have to have it cleaned. We talked about that in the last webinar with the cleaning and inspection and the percentage of it. So you can do all the right things of fiber routing, but you also have to start with it cleaned and also inspected. Don't you agree?
Absolutely. And if I may add one other thing, you know, since our focus is on fiber routing, if you go back to some of those images with the rat's nest of jumpers that you're dealing with in front of a piece of equipment that has a magnitude of fiber jumpers, they've just grown so exponentially over the years with how many fiber connectors are within a particular piece of equipment. You know, one of the things that we talked about on the last webinar was making sure that you not only clean the connector, you also clean the bulkhead that you're plugging into. It's very difficult to access that bulkhead if you have a bird's nest of jumpers all around it and you're trying to get your fiber cleaning equipment inside that bulkhead to inspect and clean. So, you know, the two are kind of tied together in that, you know, I can't properly clean a bulkhead if I can't get to it. So if I can't get to it, then I may make the excuse that I'm not going to clean it and inspect it because I can't get to it. And I can't get to it because the fibers have been mismanaged for however many length of time it's been there.
So we're going to have a slide that shows that rat's nest as you discussed. I think it's the next slide or one right after that. And we'll point some of those things out that you had mentioned. You know, what's also important is we get further down the line of larger quantities of fiber. This has always been around, but strain relief. You know, you've talked about BIF fiber, bend-insensitive fiber. There's so many different series of that now. There's also UBIF, which you can even have a tighter bend. The problem happens, though, is that you got to have the proper strain relief, and that depends if it's an older legacy product or even in a newer product today. What does that look like? Take a minute to talk about what strain relief should do and why you should have it.
So the strain relief a lot of times is just taking the stress and taking the pressure off of the connectors. So when you have connectors that are plugged into a network panel or in a piece of equipment, you know, you don't want to have excessive amount of strain on those connectors where it's going to potentially create a bend radius issue, especially on older fibers. As you mentioned, bend-insensitive fibers. So back to my analogy with the hose, bend-insensitive fibers, if I took that hose and bent it in half, the water would still flow out of it if it were a quote-unquote bend-insensitive fiber. Same thing with jumpers. So when I bend that fiber, you know, significantly beyond the bend radius allowance, right? Not pinching it in total half, but, you know, significantly beyond the bend radius, light is still going to transition out of that connector with very little adverse effect. But you still want to have that strain relief at the connector because, you know, you're not going to be able to have connectors plugged into a piece of equipment and have them banjo tight, and they're going to begin to, you know, put a lot of stress and a lot of strain on that boot of the connector. So strain relief, you see a lot of times where there'll be a loop, a service loop, if you will, to kind of help with some of that strain. Also, too, as you see with the image there in the upper right-hand corner, you'll have fibers that may be routed through channels that have some sort of protective plastic, or you'll have connectors that are tied to framing equipment inside the space that are protecting the connectors from however it's being adhered to the frame. Meaning, if you're using wax twine, if you're using tie wraps, whatever that connection is to the frame, you would have some sort of protective wrap. In the field, we usually call it fish paper, or you may have some other form of way to protect that connector, and that's just to prevent any sort of long-term friction on that connector and potentially reducing that flow of light, if you will, but also to protecting it from any kind of any sort of vibrations where it might begin to create friction and rub on the connector, as you see there in the upper right-hand corner.
Yeah, that's a great point. One of the things that we wanted to also address as how do you future-proof your network? One of the things is whether you're using you're going to use the patch cables on the left as well as the trunk cables. The neat thing about how the industry has moved is, years ago you'd have a variety of connectors, and then you had variety of lengths, and then depending on the whether it's a 6 or 12 pack and how it was laid out. Today, what's neat is that you have, whether it's patch cables or trunk cables, the ability to have polarity reversible. So whether it's polarity A or you have to reverse it to B, you can do that with the same cable. You don't have to buy two different series of whether it be patch cables or trunk cables. Also, when we talk about like uniboots or extended latches, some slides prior to this one, it showed a blue extended latch. So when the tray is recessed and you need to take out that small form factor connector, you're not getting your hand, the technician doesn't have to put their hand in there and disrupt other active fibers. So they're able to do that because of technology such as the extended latch. And then another thing on the trunk cables is that we call it gender reversible, meaning that instead of having, I have cords that are, especially in the MPO world, they're pinned or non-pinned, so they make that connection. You can actually change the polarity, A to B, but then you can also change whether it's a pinned or not. So now that connector becomes very useful or scalable, flexible in your network. So you're only dealing with one connector, one jumper, and you can change and morph it according to your design. It also has pre-terminated breakout lengths and then pulling eye, as you can see for the grip option. So there's a lot of advancements and innovation that's going on in fiber routing today. What's passed on. The key is whether it's going to be used or not by the technician or by the companies. Now the next one is, if we go back a couple slides, you'd mentioned about the rat's nest on the left. This picture, Dustin, I hate to say it, was taken, and when it was provided to me, was of a new build just recently, probably within a couple years, and I think that's probably where you inherit a mess, and that's something new. So this isn't an old picture. This is a very new picture of a new network, and it's really a shame because someone has to go in there and troubleshoot. And as we talked about, when you inherit a mess, it's all right, well, what do you do to troubleshoot it? And on these slides here, or this slide, I wanted to show that there are some ways, especially as you move into more of the multi-fiber, whether it's a fan out or whether it's an MPO of 12 fiber connector to a 12 fiber or a 24 to a 24 in one connector and the ribbon cable. You have the opportunity of using, and still this has been an old technology that's been advanced called optical fiber identifying. And you're able to see if you have light, not traffic, but light on that fiber. The technology to the right allows, like that rat's nest to the left, is a multi-fiber identification system. So you're able to put multiple lights over that fiber and detect whether it's active or not. And then last but certainly not least is the ability to measure power. So today, because this isn't going to go away, it's still out in the system, which is inheriting a mess. Companies have to produce products to be able to help the technician find and run trouble, to find where the issues are, whether they be the brakes or some type of, as you mentioned, Dustin, hoses that are bent and, leaking water. And in this particular case, maybe leaking some light out. So not sure if you wanted to touch on that at all.
Yeah, so it's, and as you mentioned, if this is with this being a new install, it's going to make things a lot more difficult as things progress. And the reason for that is that if you ever did want to take the time to try to fix that, obviously you would be taking services down to go ahead and try to correct that and make that a little bit neater. So it's sort of a shame where, you would end up having to take, and you can see how many fibers are there and take that volume of fibers out of service or, intermittently drop certain customers at certain periods of time as you try to go through and fix that. It all begins at installation. And once you are presented with something like that, and once you inherit that kind of mess, it makes it extremely difficult to try to fix. And but no, you're right. There are definitely tools out there to go ahead and try to run your traces and locate your fibers and various OFIs and fiber identifiers and so forth. And sometimes it's just a matter of running your fingers across it and try to figure out which one's yours. But as you go through and try to do a installation or a disconnect on that particular mess, and there's a lot of potential there taking other customers out of service in the process.
Yeah, you're not kidding. That's I wouldn't want to run trouble on that one. I think I'd pass. So we're at the last slide, and what we've done is a checklist here of fiber routing best practice summary. And 1, 2, and 3, Dustin, network and infrastructure planning. I think you talked about that with the engineering. Make sure the engineering is sound and the planning, and then just like the manufacturers, they all send documents out to follow. Whether you follow them or not is whether you build your foundation and you anchor into something solid. And then obviously it goes to the installation. And then obviously, which is, we've seen over time, Dustin, is network documentation has, if it hadn't started early on, then it doesn't get better, right? It's very difficult to get better. And so we wanted to put this checklist together after you and I talked, and didn't know if you want to just touch on any of this since it's our last slide.
Certainly. And as you pointed out, when it's not taken care of from the very beginning, it'll snowball. And again, it's, when you initiate, when you first start out with bad practices and bad fiber routing, then you have sort of given those that come in behind you the carte blanche, or the excuse, if you will, to continue that bad practice. So if you start out with a very good, clean, well-managed installation, it'll continue that good practice. Typically, will continue that good practice on through. But the other thing too that all of this kind of ties into is growth of the network. And as you need to swap out equipment and be able to manipulate different pieces of equipment inside your network, it makes things a lot easier when everything's managed neatly to switch out equipment, upgrade equipment, move equipment around, whatever the case might be. It really definitely makes things a lot easier when it's managed properly to go ahead and try to stay current, try to upgrade your network, try to increase your volumes, etc.
Yeah, absolutely. And as we go forward here, we know that throughout this presentation that we've been taking questions, so we're going to address as many questions as we can during the time that we have left. So, Dustin, I have a couple questions that came through the chat room. I think the
All right.
first one, let me go through. All right, here we go. It's difficult to always know how long of a jumper I need. Is there a better way to have the length predetermined? So I just need to grab and go, knowing my jumper will be long enough, but not too long.
Huh. Okay. Yes, actually, there's a little trick that I employ. So what I'll do is I'll take a piece of twine, measure it out, take a little Sharpie marker and mark out, 1 meter, 2 meter, etc. And if there's a panel or a set of LGXs that I commonly use, I'll just take that piece of twine and sort of run it and get predetermined lengths and kind of identify those. And I'll jot them down on a piece of paper, and I'll go ahead and maybe make myself a little job aid. And that way I know that if I'm going from point A to point B, it may be this predetermined length. Point A to point C, point A to point D, etc. And then also, too, some of the very intricate fiber panels that exist on the market, some of those do have little booklets and little charts that tell you and guide you what length jumper you might need if you're going from panel 1 to panel 7, and you have X number of bays in between. You might need this length jumper. So yeah, there's a couple little tricks there to kind of get your self worked out beforehand.
All right, thank you. I got another one here about bend radius. Dustin, this is to you. So you talked about bend radius. When a fiber is bent, how can I find that in that bird's nest of jumpers that may span between several floors and a large number of bays?
Yeah, so yeah, if you do have in larger network data centers, central offices, et cetera, where you have jumpers that are ran across a very long span between multiple floors, et cetera, there are tools out there that exist. There's things like red light that you can use as a fiber identifier. There's also various OTDRs and intelligent OTDRs that exist on the market today, and they can actually pinpoint length as far as where there may be a bend radius issue, where there may be a bad connector, dirty connector, etc. So there are products out in the market that can help you identify where your bend might be, and even also cleanliness on the connectors. It can identify where you have a dirty connector. So yes, those do exist, and typically they're found within varying OTDRs and intelligent OTDRs.
Yeah, that got really, that kind of talks about, talks about like return loss, right? Because the cleanliness is also affecting the optical return loss, which obviously the intelligent OTDR can pick up as well. Don't you agree?
Absolutely.
Let's see. Also want to invite on Mr. Kevin Clayton. He is our senior product manager for Inside Plant. I have a question that came in the chat room, Kevin, for you. It says, based on the high density platforms, what is now the advantages of front, rear, and top entry? Can you describe or give an overview on that?
Absolutely. So I think there's two aspects to that. The first aspect is going to go to kind of the design intent from the very beginning, enabling its scalability. Okay, so when you're thinking about where your network is going, I think there's just a sheer amount of fiber, as you discussed throughout here, that you could have really requires, if you're going to try to scale, that you really have access, in the front, in the rear, and on the top, to be able to get in there very effectively and allow the technicians to do adds and drops as they go to grow the network. And then the other piece, obviously, is when you think about the maintenance side of things, and when you do get that many fibers in a panel, again, some of these high-density panels now, you have a lot of fiber and a lot of money running through those bandwidths that are coming in and out of that panel. So you want to be able to get to those fibers very effectively after the fact and having access from the front, from the rear, and then also from the top kind of enables you that ability to get in there without disturbing a lot of the other fibers around the individual ports that you're trying to get to. So it doesn't really matter whether it's an LC or whether it's an MPO, having that access in front, back, and top really enables you to get in there effectively and do adds and drops.
All right, I got 2 more questions on the chat room. Kevin, this one will go to you as well. Somebody wrote in and said, can you provide a little bit deeper dive on the pinned and non-pinned, how that works, being able to switch out on an MPO?
Just real quickly to hit that one again, really just think about it from the perspective of, again, that gender, that male female approach of pinned and not pinned. It really comes down to how you have your network set up to go to that active equipment, how you're going to interface with those MPOs and the cables that you're trying to run to and from, both in the rear and in the front. So having that ability to do the gender reversible in the field just enables that if you come across something that a system that's already set up, you have the ability to both put in new from the perspective of having something pinned, and then if you're trying to address things that are already in the network, you have the ability to go back to non-pinned if you need to have that mateability out there in something, a system that's already installed.
Awesome. Thanks, Kevin. Appreciate that. Justin, I have one more for you that just came in, and it said, so would you start documentation from the beginning? And this is kind of, I don't want to say cryptic, but it's, let me try to, it says, can you start documentation from the beginning and also add to it from the field? So I think what the person's asking is, when you install it and you have the documentation, does the field then take that and add to it as they upgrade it? I think that's what he's asking.
So yeah, I mean, it's always important to take whatever the manufacturer provides you, right? Whether it's different fiber panels or different network pieces of equipment, and they lay out inside their documentation how the fibers should be run to make it successful within their piece of equipment. It's imperative that you take that information and use that to make it work within your network, right? So just because the manufacturer provides it to you and says, this is what we think that you should do, won't exactly always fit every single need that would occur in the field. So it's important to go ahead and take that feedback from the field and update. If you have your own internal documents written for your own network within your corporation, to take that information and adjust it to your needs, certainly. And in some cases, it doesn't always hurt to also take that feedback back to the manufacturer and say, hey, look, we went ahead and tried this, and this is something that we noticed when we were working in this type of panel, and it wasn't really working, but when we tried this, it did start to work, and then they can go ahead and make their adjustments accordingly. So yeah, it's always, those types of documentation are always living, breathing documents, and they can always be updated, modified, corrected. Yeah, so it's certainly, but you also want to take that information and use it how it'll work best for you in your situation, right? It's not necessarily something that is set in stone. It's a living, breathing document. So you always want to make those adjustments within your network.
Gotcha. Well, I think that is all the questions I have that have come through on the chat room. And so as we finish up here, I want to thank the audience for the participation and the questions and just the time. I know everybody's busy, but to be able to take time out and jump on a webinar is always, hopefully this will be fruitful for everyone. Also want to thank Dustin as our subject matter expert. Thank you, man. Appreciate your openness and willingness to be on here.
Certainly. Thank you for having me.
No, always, man. Thank you. I want to thank our marketing team because without them, we couldn't put these types of informational editorials together for folks through a webinar series. And so I want to thank Mary Ellen's group and Nicole and Yelena and Phyllis and Barbara for putting all this together, for Corey helping in the background as well. And then Kevin, man, so thankful to have you on here as our Senior Product Manager. Thank you for your time. And folks, at the end of this, you will, if you've registered, you will be able to get an email will be sent to you with a link. So if you want to go back to this and reference it or anything you need, you'll have access to it. So I want to thank you guys for being on, and hope to talk to everyone again very soon. Have a great day.